Hey, welcome. Happy day. I am up early today. I mean, not really. It's kind of normal time. But I got a little bit of time, and since the problems have been easier this month, figured I'd go ahead and do it. And today's problem also looks easy. And when I say easy, I mean LeetCode's definition of easy. So, depends. So in this case, we're given a sorted array consisting of only integers where every element appears exactly twice. Sorted array, and every element is twice except for one, which is exactly once. Find this single element that appears only once. Okay, so we had a problem like this back in April. Hey, thanks for a like. Good morning. Or whatever time of day it is. And in that problem, there was a really cool trick where you can XOR the items, and what happens is things would cancel out as you go along. So that's a really easy way to solve the problem. So the 1 and the 1 will cancel out. We'll have the 2. And basically all the bits will keep canceling out until we're only left with the ones from the 2. The solution should run in log n of time in O of 1 space. So if we're going to run in log n of time, that means we can't look at every element in the array, which is a pretty big hint how we have to solve the problem. So in the second example here, we can see that we've got numbers that are out of order, so we can't rely on getting 1, 2, 3, 4. In this case, we have 3, 7, so we can't just compare the index because we're splitting numbers, so we can't just kind of hop to a number and see if it's too big or too small for its location. The only other thing then I could think of is basically a binary search. So that would let us skip around and divide the problem space in half every time. But how do we know to go left or right? Oh, hey, what's up, Abhishek, Andres, and Ravish? Ah, and hey, thanks for the kind words, Ravish. Let me fix the chat real quick, like I do every day. And then, yeah, binary search is going to be the way to do this. And the way to tell when you should go left or right is going to be basically whether your index is even or odd. I think. I still haven't fully thought this out. Alright, chat should be fixed. Nope. Let me do it again. Let's try this again. I'll do this every day. I click the refresh button. Come on. Alright, maybe it's not going to work. Maybe it's just running late. We shall see. Yeah, thanks for the kind words. Yeah, so in this case, we hop to the middle, and we can see that the middle is odd. What does that mean? If the number is odd, that means that we've already... Oh, we check the one to the left and to the right of us. And then based on our index being odd, we know that the one to the left of us should be less than. Okay, and it's not, which means we've already passed the incorrect number. So that we can hop left. Yeah, this is kind of tricky. Maybe I underestimated this one. Let me try and fix chat one more time. This is driving me nuts. Go in here, we click properties. We get this super wide window. I come in here to source and I say refresh. I can, And that usually fixes it, but not today. Let me click around some other random thing. Whoa. I don't know. Alright, I give up. I don't know what's up with the comments today. We'll live. What's up, Ajay? I saw something disappeared. It says message retracted. Sometimes YouTube chat doesn't like links. So let me go ahead and take this over to IntelliJ. Use it. Control Alt Insert. And what do we call this one? Single number test. All right. So just to lay out the basic algorithm, it's going to be a standard binary search. So what we'll do is we'll have a start equals 0. We'll have an end. Which is going to be nums.length minus 1. And you think I've done enough binary search algorithms lately that I should know how to do this offhand. Well, current equals, what did we say this was? End minus start, so we don't overflow, plus start. I believe that's correct. And let's see, maybe we can figure out how to exit out of here. And basically there's two conditions, three conditions. Is this the answer? Should we move left? And should we move right? So knowing how to move left or right is, or rather moving left or right is easy. So if we move right, it means changing our start, so it moves in. Wow, thanks for all the likes, appreciate it. So the start is equal to our current plus 1. If we move left, our end is equal to current minus 1. So we're always shrinking the range. You gotta remember this minus 1 and plus 1, so we don't end up in an infinite loop. So I still need to figure out the shoulds. So, if this is the answer, how do we know? Well, if nums at, I'll have to do some boundary checking here, current minus 1 is not equal to nums at current, and the number to the right of me. Ugh, it's gross. Yeah, Vlados, it is early. It is early. Thank you. Thank you for acknowledging me and providing me with an excuse. It's so early, I can't think straight. Ah. Alright, so this is a pretty yucky check here. And it's not even sufficient because I also have to check basically if we're the first or the last one. And I need to do that before I check this, which is just crazy. Gross. There's got to be a better way to check this. Yeah. Oh man, I know about Dr. Belt's taking a while. Let's see here. Especially if you're like restoring data from a database or something. Or if you're doing Java and you're like downloading a bunch of packages, or I guess NPM too. Same problem. So I still have a lot of work I need to do. Even if just telling what if it's the answer is surprisingly annoying. So I have to know if it's left or the right, or I'm just gonna write it out in separate ifs and figure out how to combine them together. Nums at current plus 1 is not equal to nums at current. And current equals 0. $400 megabytes. Wow, that's awesome. Yeah, that's a good chunk of data. Current. I should name it first. So maybe is first item is first. I don't know. Like is first. Maybe is first unique. I don't know. I don't know what to name this, but the deal is if it's the first item in the array and the number to the right is not our number, then that's our item. We also have to worry about the case where it's last. Equals nums.length minus 1, size minus 1, and this. The one before us is, so I'm getting all tripped up. So here I'll just say, I don't know, is right equal. There we go. Is left equal. And I'm going to try and figure out how to compose this so that I don't get any overflow errors. I don't know why I'm having such a hard time here. Alright, is last. And is last equals that. Alright. Yep, start it up again. Alright, so got the conditions. These two may not need to be checked, or rather I can't check. So if it's right, it's not is last. And here it's not is first. Okay. So what do we got here? So are we the first element? Are we the last element? Is our right is equal to what do I want the answer to be if for is right equal? Oh, I think I want to say we want to consider the right one equal if and only if it's not last. So if it's not last and the one to the right, okay. So then is left equal should be we're not the first. Hey, the chat started working again magically. For a while there I was running some stuff that would take like 20 minutes to get started because I would have to load a bunch of data in this process. Working on that thing was miserable. Tests are great for stuff like that. So otherwise, 20 minutes every time you want to check and see if something worked, that's unsustainable. Not first, and the item to the left of us. Okay. So, down here, if not is right equal and not is left equal, then we can return our number. Nums at current. And we'll just keep with the infinite loop because I'm sure this is going to be fine. Alright, so now we've answered the question, is this the answer? Group that together. Now we need to figure out, should we move left or should we move right? And then we're done. Let's see here. Should we move left? When should we move left? Let's grab an example. All right, how do we know to move left? So we've got 9 items. So if we look at our algorithm, 9 minus 0 is 9 plus 0. I forgot to divide by 2. 9 divided by 2, 4 plus 0. 0, 1, 2, 3, 4. So we say check first, last is right equal, is left equal. The left is equal, so we don't return. So now what? I'll just do this. If should move left. Else we move right. Alright, now, so we've already checked if it's equal. We just have to figure out, should we move left? And we're looking at the second 3 here. Any ideas? If our index is odd, so current mod 2 equals 1. And in this case, our index is 4. Zero, 1, 2, 3. This one. Index is 4. Start plus n divided by 2. I don't know. What's the difference? Start plus n divided by 2. Does that give the right answer? So if we got 4, 9, 13 would be 6. That's also correct, as compared to 9 minus 4 is 5, divided by 2 is 3, plus start is also 6. No, it's 7. But either way, yeah, I don't know, Vlados. Why don't I do that? I think I just did it this way once and it worked. I just kind of stuck with it. I guess potentially the number doesn't get as big here, so I don't have to worry about overflow. Yeah. If it's a huge array, then this number will keep it smaller, but I think that's very unlikely to have 2 to the 31st indexes. Alright, I'm doing it. Let's see. Start plus end over 2. Thanks, Vlados. Alright. So we're looking at the second 3. And our current index is even. Which I think what I would want to do is actually check if it's even. N divided by 2 plus start divided by 2, yeah? Yeah, divide both sides by 2. Start minus divided by 2. Okay, yeah. Wow. Too early for math, man. Come on. So current mod 2 equals 0. So in this case, we're saying our current index is even, which means yeah, I should spend more time. I should take like an algebra course. It's been a long time. I think it's letting my brain rot. Okay, so basically the information I have is whether we're odd or even and is left equal or is right equal. Docker! Hey, Messietti. Hope I said that right. Hope you're having a good one. We're doing a problem here where we're trying to find a single number that is not duplicated in a sorted array. However, they gave us the extra stipulation that the code should run in log n of time, which so we cannot look at every input. Hey, what's up, Zach? Hope you're having a good one. Just trying to find the item in a sorted array that is not duplicated, but the trick is they want us to run an O of log n. So we can't just like XOR all these things together and see what we have left. We actually have to kind of hop in here and then based on, well, let me pick a different example. Here we hop to the second 3 in like a binary search. And then the trick is we know our index is 4, which is even. So we would expect to have our right element be our duplicate of this item, but it's not, so that means we need to move left. So because it's even, and I'm just going to write out a lot of variables because I'm getting confused. All right, see ya, Mazzetti. So should move left equals is even, and is left equal. Okay, and that's it. Let me double check that. Is even, is index even. Let me name that again. I kind of want to put together a bunch of binary search problems because it seems like I keep hitting them lately and they just take me longer than they should. Like, I recognized very quickly that this was a binary search solvable problem, and here I am still messing around with it. To be fair though, I am a chatty Chad. Alright, so we got an example here. So here, there's 9 items in the array. Is that right? Yes. And so we first hop to index 4, and then we say, are you even? Is the index even? Yes. And then what do we say? Is your left equal to you? Yes. That means the problem is before you. The single element is before you. So it should move left. Alright, so in that case, now we should set the endpoint to our current midpoint -1, so right here, and then start over. Now we're going between 0 and 3, so it's going to be 3 divided by 2, so we got 1.5 rounded down to 1. Alright, now here we'll say, are you even index? No. So then I should say you have to move right. So now we'll start at current +1. So we'll say between 2 and 3. So we'll get 3 minus 2. Start plus end. So we'll get 5 divided by 2. So 2.5. So our current is going to equal 2. And then our checks up here should catch this. So yeah, that should be good. All right. I think this is correct. Let's try testing on one of their samples. What do we call this? I don't know. First example. Yo. Solution. Single non-duplicate. What can I do here? Array of? Will that work? To int array. This is Kotlin. I love Kotlin. It's got a lot of nice helpers, but it's kind of annoying sometimes too because it's very strongly typed, so it means you have to do some kind of annoying casting stuff that you wouldn't have to do a lot of times in a lot of languages. But it also protects you. It also is very opinionated about nulls. Like it makes you handle every potential null either by telling it that it won't be null, promising it, or having either a question mark or bang bang on the end. Which I like that, so prevents errors, and it still feels nice and light to me. So I like it. Equals, and our the one we expect here is 2, and there we go. Fingers crossed. I do miss JavaScript just because it's so simple. There's only like, you know, not very many built-in functions. Well, let's go ahead and debug this fella. I still have so many ingrained habits from working in C# so long. Like, I always forget the shortcuts. Step into. There we go. All right, so I want F7 and F8. Hey, very nice. Yeah, I imagine learning Java and Python at the same time has got to be kind of frustrating. It's like Python, it makes things so much easier to just do, you know, kind of what you're thinking. And Java tends to kind of make you hop through a bunch of hoops and have a bunch of boilerplate, so it just gets noisy. But the libraries in Java, very nice. But I mean, Python libraries are no joke too, so it's all good. Got a current of 4. That's what I expected. It's not our first element. It's not our last. It's not right equal. It should be left equal. Let's see. So here we got is right equal is true. And that's not the case. It should have been is left equal. What? Index 4, 0, 1, 2, 3, 4. I got these backwards somehow. So in order for my right to be equal, the number to the right of me, needs to be equal. Hey, very nice. Yeah, Abdul in here does C++ for his coding challenges, and it's awesome. And I'm really impressed with how streamlined his solutions are. They can look more trimmed down than Kotlin can, and it's so much faster. It's incredible, and much less overhead. It just does exactly what you're telling it to. No big bloated heaps. All right, so now we check this, and that should be good. So now if we run this, we should get the right answer. Yay, okay. I think this is it. What edge cases have I not thought about? Grab this one. Maybe we'll check the case where there's only one item in the array. They did promise us that they would never send us an array that didn't have an answer. So I'm not worried about the infinite loop. Oh, this is taking a while. Taking a long while. So we probably got an infinite loop here. So what should have happened? We got 7. So we should have started at 3. And we should have said... It should have been this other case here, where we should move right. Let's see if that happened. right, and okay. Got our input. All right, current equals 3. So here it should have been is left equal. Is left equals true. Is right equals false. Good. So is our index even? Is false. And that's good because our current index is 3. That's correct. And should move left is false. So that's good. I gotta build again. Hey, what's up, Abdul? Don't look, don't look. I think you'll solve this one very quickly. I was just talking about you, solving problems in C++. At the debugging phase. Looks like I got an infinite loop somehow. I'm not sure how yet. So far it's correct. The bottle rhyme. Oh, 99 bottles? Thank you. Everyone make sure to check out Y'all Coding if you like this sort of stuff. And I have a feeling you do. Y'all Coding. Wow. Look at that beautiful screen. That's nice. So I'm saying I should not move left, so I'm moving right. That's good. So we loop back around. Now our current equals 2. How did that happen? Oh, current equals 5. Okay, whew. I don't know what I was looking at. So we moved right. Heck yeah, man. Step into... It's not the first item, it's not the last. We're looking at index 5, 0, 1, 2, 3, 4, 5. So in this case, right is equal, which is true. And left is not. Also good. So we don't return the answer yet. So what should happen if we're at 5? We should move left. Oh, Replit? Nice. I've never tried using Replit for Java. I don't even know what that's like. I tend to not use REPLs very much anyway, though, so I don't really miss it. Is that index even is 5? Or current is 5. Is index even is false. Correct. Should move left. I got false somehow because the index is not even and we're not equal to the left. Or 5. So in this case, I should have moved left. I should have moved left, but I didn't say to move left because is index even is false. And our left item was not equal. You know, maybe I don't care about what index we're on. Is that... I don't know if that's true. So this, in this case, is left is equal. So I have a feeling that this is index even, maybe changes with what? No? 1, 2, 3, 4, 5. Oh, you know what? If the index is even, we should check. We should check if left equal. If the index is odd, I think we have to do something different. So if the index is even and our left is equal, then we should move left. Or it's not even and is right equal. Is that right? Let's try it. Try the first example. It's kind of boiling my brain a little bit. First example is still good, and now the second example should be good. What? This is the part that's incorrect. I don't know. So we hopped to here. We said that was good. You should move right. So we hopped to here. Now I need to move left. But how do I know to move left? The index was odd. And my right was equal. So that means we're wrong. Or rather, we're past the single element, so we should move left. So this should have moved left there. And then what? Then we should have set our ending point equal to current minus 1. So 10. So start and end should have been the same. In this case, we should have said, you're not last, and this condition should have hit. So how on earth did we get 2? What did I return here? What? Oh my gosh. Oh my gosh. Yeah, if start equals end, you can just return value 2. But in this case, that wasn't even... Like, check it out. What I did here is I was looking for expected of 2 because I copied and pasted the test. The actual answer was correct. Yeah, exactly. But tests are faulty. Alright, one more test maybe for a single item. Gotta protect my ratio. I gotta heal my ratio of submissions. So I should get a 3 here. And we should check the last item too. Guess first and last maybe. Do like 1, 2, 2, 3. And the last item, and that would be pretty good. I think we handled those cases though. Oh, this is not good. Okay, 2, 2, 3. Should be 3. Yeah, good call. Thank you, Zach. That could have been bad. All right, so that looks good. Ugh. That looks good. So now if we run all tests, we're all good. I think this is it. We're log of n. I'm not going to win because of all the stuff I have. I'm sure we could find ways to like reduce this down, but I think it's going to be more than sufficient. Let's give this a shot. Fingers crossed. Compile error. Let's try this again. And hopefully this works. Gonna hit submit because it's time to go to work. All right, yay. Let's see how we did. Okay, hey, look at that. Better than average. Whoa, what? Wow. Yeah, exactly. DDD. True DDD. What? Wow, low is less than high. Low is 0. High is the end. The midpoint equal. Oh, okay, that's just their start and end. Okay, that's fine. If mid mod 2 equals 1, so that was their condition that I checked for, basically is even. Then they do mid minus minus. Okay, move left. No, that's weird. If numbers at mid equals, and they increase the low. So it's binary search. Return nums at high. And they keep track of the high mark, and then they look for the first high that doesn't match up. So always end up finding the right side value and returning that. Alright. I'll accept it. Alright, I got 5 minutes to go get coffee before starting work. Thanks for hanging out. Thanks for all the likes too. Appreciate it. Y'all have a good one.